Okay, on this we're going to find we're going to work on logarithms. And if I go back and I ask you to solve a problem like this, if I say find x if 2 to the x power equals 6 to 3 decimal places. Okay. You might estimate that and say, okay, I know 2 squared is 4. I know 2 to the third is 8, so it's got to be somewhere in between 2 and 3. But I want it to 3 decimal places. Okay? We'll come back to that. Okay, we'll come back to that problem. Okay, first of all, if you forget everything else about this section, okay, a year from now, 2 years from now, 3 years from now, what I want you to remember is a logarithm is just an exponent. And most of you know all the rules for exponents. We'll go through them here in a minute. But if you forget everything else, just remember a logarithm is just an exponent. Okay? In Algebra 2, you talked about exponential form, radical form, logarithmic form. You ought to be able to go back and forth. Make 3 columns. And if I give you something in exponential form, you ought to be able to go to logarithmic form, and you ought to be able to go to radical form. Back and forth. It's like when you do arithmetic, you ought to be able to go from fractions to decimals to percents, back and forth. Same idea here. Okay? If I gave you 10 squared equals 100, okay, that would be considered exponential form. Remember, this is considered the base. The 10 is the base. Okay. This is the exponent, and this is the number. If you go to logarithmic form, okay, it's the log of the number, log of 100, base. The base is always written as a little subscript, base 10, and it equals 2. The logarithm is just the exponent. Okay. For right now, we're not really going to worry about the radical form, but you should be able to go back and forth. If I did something in radical form, example, like if I did the cube root of x to the 4th, okay, that's radical form. What would that be in exponential form? X to the 4 thirds, right? This is, that index is the denominator. This is the numerator. Okay, you ought to be able to go back and forth. So anything to the square root power is to what exponent? 1/2. Anything to the cube root would be to the 1/3 power. Okay, but we're not going to worry that much about the radical form right now. You did that in Algebra 2. We're going to go exponential and logarithmic. Okay, if I said 1,000 is the same as 10 to the 3rd power, then to write it in logarithmic form, it's the log of the number, log of 1,000, base 10 equals 3. Okay. On your calculators, you have an log, a log piece, down in the left column. Okay. If you type in, let's try the log of 100. Log of 100 we said was 2. Log of 1,000. So when you're finding that logarithm, what you've really found is 10 to what power equals 1,000. Okay? Okay, and it ends up to be 3. Okay? if I type in on the calculator, let's do like the log of 56. Okay. And you do these a lot in science, in your, especially in your chemistry, physics classes. You're going to use logarithms of a bunch. Say the log of 56, and we're going to round it to like 1.7482, something like that. Okay, what this is, it's basically saying 10 to that power equals 56. Now, on your calculator, if you're going to check it, look right above the LOG key, right above the log key in yellow, 10 to the x. Okay, so let's do second function, 10 to the x. Well, it gives you 10 to what power? And then let's do second function answer. And the answer is right above the negative sign. So it's basically going to fill this in to right here. So do second function answer. And it should take you back to 56. Okay? So it's saying 10 to the 1.748, and that's rounded. Okay, whatever that exponent is, would bring you back to 56. That's the exponential form. So when you're taking the logarithm on the calculator, you're really finding 10 to that power. What's that exponent? Okay. Okay, those are all, when I write these, and I notice on this one I didn't put the 10 there. If they don't have a 10 there, it's understood to be a 10. Any of these with a base 10 are called a common logarithm. Common logarithms are understood to be base 10. And the LOG on the calculator by itself is understood to be base 10. Now, when you do one like this, if I said 2 to the third power, 2 times 2 times 2 is 8. Okay, if I write that in logarithmic form, it's the log of the number, log of 8. The base is 2, and the exponent is 3. Now, you cannot just punch this in. You can't just punch that in on the calculator because it's a different base. So you have to use what they call the change of base formula. The change of base formula says it's the log of the number divided by the log of the base. Log of the number divided by the log of the base. So if I just punch in the log of 8, you can see you're going to get the wrong answer. Log of 8 is the calculator's figuring it base 10. But if I use this change of base formula, I'm going to put the log of the number, and the calculator's going to put a parentheses here, so you've got to put parentheses here. Close it. Over the log of the base. Okay, so do log of 8, close the parentheses, divided by the log of 2. Okay, and then it should work. Okay, it will give you 3 for your final answer. So if your base is something other than 10, then you've got to use this, and that's a important formula, the change of base formula. Log of the number divided by the log of the base. Okay, so if I say, as an example, if I said figure the log of 25 base 5, what you're really saying is 5 to what power equals 25, and you should know, should end up to be 2. Okay, but if we did it on the calculator, it'd be the log of the number divided by the log of the base, okay, and it should end up to be 2. Okay, so in exponential form, it's the base to that exponent equals the number. Okay, so you ought to be able to go from logarithmic form to exponential form back and forth. Okay, okay, now I want to go through laws of logarithms. Okay, to be able to work a lot of these problems, you have to know the 3 laws of logarithms. The laws of logarithms parallel the laws of exponents. Okay, so let's go back on laws of exponents. And let's parallel that with laws of logarithms. Okay, the first law of exponents, if you have the same base, like x to the m power times x to the n power, when you multiply monomials and the bases are the same, what do you do with the exponents? You add them, right? X to the m plus n, okay? You add them. Okay, now, laws of logarithms. First law of logarithms. If I take the log, and they use, different authors use different letters, I do too. The log of, let's say I multiply p times q. Okay, if I take the log of the product of two numbers, it parallels this law. If I multiply the monomials, I add the exponents. So if I multiply the numbers, what do you guess I do with the logarithms? What do we do over here? We add them. So we add the log of p plus the log of q. And if you think back in the history of math, if you had a choice, would you rather add two numbers or multiply two numbers? A lot rather add, okay? Okay, second law of exponents. If you divide monomials, x to the m divided by x to the n, if you divide monomials and the bases are the same, what do you do with the exponents? Subtract them. So it would be x to the m minus n. And you may end up with a positive exponent or a negative exponent depending on their size. Okay? So if we take the log of p divided by q, if we divide the numbers, what do you guess we do with the logarithms? Subtract them. Yep, so it would be the log of p minus the log of q. Okay? And then third law. If I take x to the m power and raise it to the n power. When you raise a power to a power, what do you do with the exponents? Multiply them. So it'd be x to the mn power. Okay? And the third law, this one looks a little bit different when you take the log of p, and let's say that's to the q power. Okay, what you do is you take this exponent, take that exponent, and it's going to move out front because you're going to multiply. So you're going to take q times the log of p. Okay? Okay, so let's verify those laws on the calculator. Let's go back up to the first one. Okay, if I said I'm going to take the log of, let's say, 3 times 5. That'd be the same as log of 15, right? So on your calculator, punch in the log of 15, and we're back to common logarithms base 10. Log of 15, you get like 1.1760, okay? That ought to be the same as the log of 3 plus the log of 5. Okay, and you're probably going to have to close the parentheses. So take the log of 3, close the parentheses, plus the log of 5, and you should get the same answer, 1.1761 if you round it. Okay? So if you're multiplying the numbers, add the logarithms. Okay, what if we were dividing? Let's take the log of, let's say 20 divided by 4. Okay, so that'd be the log of 5, right? So figure the log of 5. I get 0.698, it'd be 90 if we round it, 0.6990. And then this would be the same as if I took the log of 20 minus the log of 4. Okay, so take the log of 20, close the parentheses, minus the log of 4. Okay, and you get the same answer, 0.6990 if you round it. Okay. This one, third law of logarithms. Let's say I have a log of, let's say 6 to the 5th power. Okay. So figure 6. Well, let's do it that way. Let's just put it that way. Log of 6 and raise it to the. I need that on the outside. Hang on. If I do this right. Okay, and then that would be 5 times the log of 6. Oh, what am I doing? Different answers. I don't think that's going to change it. I need that exponent on the. Hang on. On the log of 6. Okay, so let's do log of 6 and raise that to the 5th. Let's try that. There we go. Okay. Yeah, we got the same answer that way. Okay. Yeah. So I need to change it. I need to change it in the notes, don't I? Yep. Okay. Okay. And then you get 3.8908 if you did it that way. Okay. Okay. So third law of logarithms, you multiply. Okay. Okay. Now let's go back, all the way back to the beginning of the lesson. Go back to this. Okay. We said you need to find x. 2 to the x power equals 6. And you want to find that x, that exponent, to 3 decimal places. We know it's between 2 and 3. Okay. So let's actually solve it. And this is one time. It's like, why do we study x? Why do we study logarithms? Okay. This is one time where you need logarithms to be able to solve this problem. Okay. So if they say solve 2 to the x power equals 6. Okay. Anytime you have a variable up as an exponent, okay, you got to use logarithms. What starts this off is just take the log of both sides. Take the log of both sides. Okay? Make a note here. This starts it. Take the log of both sides. So you just write log on both sides. Okay? Okay, now, here's a log, a number, to a power. Third law of logarithms says this exponent goes out front. Okay? So on the next line, you'd have x times the log of 2 equals the log of 6. Now, we're trying to solve for x. Okay, so to get x by itself, divide by the log of 2. Divide by the log of 2. So we'd have x equals. Okay, so now on your calculators, you're going to have to close the parentheses. I didn't write parentheses on the problem. Take the log of 6, close the parentheses, divided by the log of 2, close the parentheses, and I get now 2.58. They wanted it to 3 decimal places, so we need a 5 there if we round that up. Okay? And if you wanted to check it with the whole decimal, you would go back and say 2, raise it, use your caret symbol, raise it, and then do second function answer. 2 to that answer ought to be 6. It'll take you back to 6. Okay? Okay. Any questions on that one? Okay, everything we've done so far has an log. Now we're going to go to ln. ln is natural logarithms. Yesterday we talked about e. E was about 2.718. E is the base for natural logarithms. But all the rules for natural logarithms are the same. Okay, natural logarithms and common logarithms. Get it okay? Got it? So now we're going to do natural logs. Okay. If I gave you the natural log of 5, okay, right below the LOG, and every calculator that's scientific is going to have an LOG and an LN. Okay, the LN is natural log. So if I do the natural log of 5 and press enter, I get like, and this is rounded 1.6094. If I round it to 4, okay, and it's understood that this is a base E. Okay. If you go backwards, this is the logarithmic form. If you go backwards to the exponential form, look right above the ln, and you see the e to the x. Do second function. Okay. It shows this. Okay, and then do second function answer. Okay, and it's really saying the 2.718 to that power will take you back to 5. Okay. So all the rules for natural logs and common logs, the laws of logarithms are the same. So if I took, if I took the natural log of, let's say, 5 times 2, if I multiply the numbers, what would I do with the logarithms? Add them. So that's the natural log of 5 plus the natural log of 2. They should be the same. Okay, so let's try it. Natural log of 10, basically. And I get 2.3026. And then take the natural log of 5, close the parentheses, plus the natural log of 2. And I should get the same answer. Okay? Okay? So the other law, the second law and the third law also work the same. Okay? Okay. So natural logs and the base is about 2.718. And I think on your, if you do any work on the computers, most of the time on the computers in programming, you have to be careful on the logarithms. Are they doing common logs or natural logs? If you're doing any computer work, you need to be careful with that. Okay, the next thing the author goes through in this section is e to the I pi power equals -1. E to the I pi power equals -1. Okay, now we know what E is. E is about 2.718. But you ought to question then, okay, what does I pi equal? Okay, what does I pi equal? Okay, so start with the original. E to the I pi equals -1. And if you want to solve this, it's base E. So instead of, it's just like the 2 to the x power is 6. We took the log of both sides. This one, since it's E, we're going to take the natural log of both sides. So E to the I pi equals the natural log of -1. So make a note here. Take the natural log of both sides. Okay, take the natural log of both sides. Third law of logarithms. Third law of logarithms says this is going to go out front. Okay, because that's an exponent. So I pi times the natural log of E equals the natural log of -1. Okay. Now we're trying to solve for I pi. So divide by natural log of E. Okay. Now, out at the side here, natural log of E. What's the base understood to be on a natural log? E. Okay, now this is logarithmic form, go to exponential. It's e to what power equals e? 1, right? So this whole thing, if those bases are the same, then x equals 1. So the natural log of e is 1. You're saying natural log of e to what power equals e? It's got to be 1. So this is 1. Okay? So I pi equals the natural log of -1. Okay? You cannot take the logarithm of a negative number. Okay? Try it. Try taking the natural log of -8. Okay? Should get an error. Okay? It won't work. Okay? But we're going to use this every time you go back and work problems. The author gives you an example in the book. Let's try one. If you said, using that, if I said, as an example, find the natural log of, let's do -350 as an example. I can't just punch that in. Okay. First thing I would do is I would break it up into natural log of -1 times 350. Right? That's still equal. Now, if you're multiplying the numbers, what do you do with the logarithms? Add them. Okay, so add them. So you'd have the natural log of -1 plus the natural log of 350. But we just figured, what's the natural log of -1? I pi. Natural log of, now we can figure that. Do natural log of 350 on your calculator. Okay, and I get, then usually they will go 4 decimal places, so 5.8579. Okay. Now, you don't have to write all the steps down every time. If you know that if it's a natural log of a negative number, it's always going to be I pi plus the natural log of the positive number. So if I said, as an example, if I said find the natural log of a -51. So my answer is going to be I pi plus, what's the natural log of 51? And I get 3.9318. Make sense? So now, if you go back on today's assignment and you look at a couple of those problems where they got this I pi, okay, now you should know where that comes from. Okay? Okay? Okay.